So we're going to look at some graphs involving work. And how do we do that? Well, let's draw a graph, sample graph. Now we're going to draw a constant force graph, and on our x-axis is going to be distance. And so since it's a constant force graph, we're going to draw our best horizontal line. So that's going to be 2 newtons, and we're going to have that go for 3 meters. Now, if I was to read off the work done by that graph, the work is just simply the area underneath the graph. So in our case, the work for this graph is going to be 2 times 3. And that should give us 6 Newton meters because we're taking a force and multiplying by a distance. Now, what happens if the force is at a diagonal, meaning that we're going to be increasing it over time? So we have force, and we have 1, 2, 3 meters. And what we're going to do is we're going to increase it 1 Newton, 2 newtons, 3 newtons. And so now again, if I want to find the work done by this graph, I'm still going to find the area underneath. It's always the same thing, but now the area is going to be the area of this triangle. So I want to say that that's going to be 1/2 the base, which is 3, times the height, which is 3. So that gives me 4.5 Newton meters. Now, the units are always going to be the same as a Newton meter or a joule, because the idea is that work is energy. Work is connected to energy. It's a form of energy. So you can use either one of those units for that.